Okay, let's continue with group anti-patterns. Over-engineering is a group anti-pattern that relates to how developers create the product itself. It occurs when a product is made more complex than necessary, such as when extra or needless features are added to the product, making it confusing for the majority of users. Over-engineering can happen on both the user interface of a product or in its internal processes. And there are many examples of over-engineering, such as digital cameras with too many features that must be set before functionality is enabled, or music players with too many options, cars that can achieve speed that it will never run at, or text editors with too many save options. To avoid over-engineering, it is important that developers clearly understand the needs of a product, what the product needs to be able to do, versus the wants of a product, what would be nice if the product could do, but it's not necessary for success. Let's continue with another group anti-pattern. Gold plating is a group anti-pattern that relates to how developer creates a product, much like over-engineering. It occurs when so much effort is put into one part of the project that it reaches a point of diminishing returns. In other words, so much extra effort is focused on a part of the project that is no longer contributes value to the product. This usually occurs when developers add extra features to the product to impress the client, particularly when the team finishes early. However, adding features can add unpredicted extra work to a project, and features that the client did not want in the project. Remember, the user requirements should be specified by the client and not by developers. And this can make the client disappointed and confused about the end product. To avoid gold plating, the developers should stop working when the product functions well. If the team feels the new features should be added, the features must first be reviewed with the client. So good question to ask when considering adding extra features include: does this feature improve the product? Does this feature make the product confusing somehow? Does this feature take away from the main functionality? Another solution to avoid gold plating could be conducting a user study. A user study involves taking a small sample of users and asking them to try out the new features on a product and provide feedback. This feedback can inform the team on how useful the feature is, how it affects the interface, whether or not the feature has broad appeal, and how the product itself can be improved. So not all extra features are bad things, but these steps help ensure that extra features add value to the product. View graph engineering is a group anti-pattern that occurs when too little effort is put into a project. It is opposite of the gold plating in that way. However, if gold plating is unfocused work, view graph engineering is working on what is not important. View graph engineering is not the same as hire a bad developer and missing deadlines, which is also a risk but a separate issue. Instead, view graph engineering is more directly tied to management practices and how those practices can make project work difficult for developers by requiring them to work on things other than development work, such as unneeded documentation and reports or creating presentations. The time spent on such activities should not be greater than the time spent writing code or developing a project. So this anti-pattern commonly occurs in organizations with vertical management structures, where developers must constantly analyze the potential of a concept and prove it to management before going forward. In this way, view graph engineering is a kind of analysis paralysis on an organizational level. Agile methods purposefully seek to avoid view graph engineering by placing focus on creating work software over comprehensive documentation. Although documentation should still be produced, it should not lead to unfocused development work. In a similar vein, the best solution to view graph engineering is to remove any barriers developers might face in developing a project. Creating a basic prototype is often more informative than any report or presentation. So time spent on such documentation may be better served in development. If the prototype is good, then it can be built upon. If it's not good, then it can be scrapped, and then the team will learn from going forward in both the project and future projects. Fire drill and heroics are two patterns or linked group anti-patterns, and both are very common. Fire drill happen when developers do very little work throughout the most of the project and then make a big push toward the end of the project, resulting in overtime work to meet deadlines. This leads to loss of quality in favor of producing a product quickly. Fire drills can have many causes, including bad management practices, or developers wasting time. Expectations were not properly established with the client. Fire drills can also lead to heroics. Heroics is an anti-pattern where the developers end up relying on only one person with technical skills to get the project done. This requires that one developer have almost superhuman skills, as he or she takes on almost the entire project. And further, the team relies on only one person, which is bad both for the team and for that developer. So to avoid fire drills and heroics, it is important to establish expectations with the client early on the project and to follow agile software development practices. For example, using time boxes, always producing a work product at the end of those time boxes. These strategies keep the team working at a steady pace, avoiding both the fire drills and heroics. They will also keep up the team motivation for the project. Dead March is a group anti-pattern that happens when developers and management are at odds because the management team is enforcing a path for the project that developers do not believe in. This leads the developers to lose conviction and passion for the project, which increases the likelihood of project failure. Despite this, everyone keeps working out of a sense of obligation. So death matches can occur because financial reasons or when management is too stubborn to recognize other ideas and the potential failure of the project. In other cases, if developer morale is low, then the quality of the product will suffer. To avoid death marches, it is important for management to maintain open communication with developers. In other words, managers should listen to what the team thinks about the direction of the project and be willing to explore other alternatives in project development. In some cases, simply reassuring the developers that you understand and recognize their concerns is all that's needed to avoid a deathmatch. Okay, now let's take a short break and then we will continue with individual anti-patterns.